Welcome to GCSE Quantitative Chemistry with Mrs. Castanera. This is lesson 5 and this is a higher tier content lesson. So only higher tier students should be completing this lesson. Now our keywords today are solute, solvent, solution, concentration, mole and mass. And we've met most of these before, but by the end of the lesson you will know what all of these mean. So here we have the specification describing what we're going to be doing today. I'm going to start out by completing the knowledge check. Okay, and we're on page 23 of the higher tier booklet. So pause the video whilst you complete the 8 knowledge check questions, please, and then we'll go through them. Okay, so let's review our answers. Question 1, define MR. Well, it's the relative molecular mass of the compound, or you can add up the AR, the atomic mass, of all the atoms in the compound. Now make sure you're using a pen of a different colour to mark your work and add in any changes or corrections you need to make. Or tick if you get it correct. Question 2, define solute. So the solute is the dissolved substance, such as salt or sugar. Define solvent. So solvent is the liquid used for dissolving, such as water or ethanol. Define solution. So solution is the solute dissolved into the solvent. So salt water, sugar water. Question 5. Name the smallest subatomic particle. Well, that is the electron. Question 6. State where the mass of an atom is located. That's the nucleus. Question 7. Give the value of a mole. That's 6.02 times 10 to the 23, and we usually add the phrase atoms afterwards to be clear that we're talking about atoms. Question 8. Give the units measuring mass. Well, that's grams or lowercase g. So if you could give yourself a mark out of 8 for that, please. And questions 2, 3 and 4 we haven't done in a while since Key Stage 3 when we're in year 7 to 9, so don't worry too much if you didn't get those yet. Okay, so today we are going to explain how the mass of a solute and the volume of solution are related to the concentration of the solution. We're also going to calculate the mass of a solute in a given volume of solution of known concentration in terms of mass per given volume of solution. That sounds quite complex, but don't worry, we will demystify that and make it very clear as to what to do. Okay, so we're going to move to the next page. Solutions. A solute is a solid that dissolves in a liquid solvent to form a solution. Okay, we're going to write something out about this. Solute plus solvent equals solution. An example of that would be salt plus water becomes salt water, or sugar plus water becomes sugar water. Changing the amount in moles or the mass in grams of the solute will affect the concentration of the solution. So essentially, the more or less solute you add, this will change the concentration of the solution. Changing the volume in decameters cubed or centimeters cubed of the solvent will also affect the concentration of the solution. So if we change the amount of either the solute or the solvent, it's going to affect the concentration of our solution. Okay, so this table here is factors that affect the concentration of the solution. So to create a high concentration, to create a high or low concentration, so to create a high concentration, you're going to want to increase the amount of solute, so that's the substance that's being dissolved, grams or moles, and you're going to want to decrease the amount of solvent. So that's the amount so if you imagine this with squash, to create high concentration of squash or a strong squash, Okay, you're going to want to put more squash in and less water, so less dilution. Okay, that's going to give you a strong squash. If you don't like your squash strong, you like it weak. Okay, so when you have your orange squash, you like it weak. Then you put less of the orange squash in. Okay, and you put more of the water in. Okay, and that will give you a weaker or lower concentration of squash. Okay, so put in brackets, these are strong solutions and weak solutions. Okay. And you need to know how to do this, okay? The units for concentration of a solution are a combination of the solute and the solvent. Okay, so it's either grams per decimeter cubed or grams per centimeter cubed, or sometimes we measure it in moles. So it's moles per decimeter cubed or moles per centimeter cubed. So the equation for calculating concentration is that concentration is mass divided by volume, or concentration is amount divided by volume. Now, the only real difference is that amount is moles and mass is grams. Okay, we're also going to highlight the different units for the concentration of a solution. There we go. Okay, so key information here. You also need to be able to rearrange these equations to make amount, mass, or volume the subject of the equation. Converting units of volume. Okay, so it's all about conversions. Sometimes you use centimetres 3 or centimetres cubed when the volume of a liquid is quite small. So for example, in a test tube. Okay, for larger quantities, we use decameters cubed. Okay, so this is the size of about 2 pints of something. So for example, a 2-pint bottle of milk, that's around about a decameter cubed. So to convert from centimetres to decameters and vice versa, that means the reverse, we use the following calculations. So whatever you've got your numbers in centimetres cubed, you divide it by 1,000 and that gives you it in decameters cubed. So 100 centimetres cubed divided by 1,000 is going to give you your answer in decameters cubed. If you want to do it the other way around, say you have 0.4 decameters cubed and you multiply it by 1,000, that will give you your answer in centimetres cubed. Okay, so we're not going to be able to do the next activity as this is not practical. Okay, we can't do practical work from home. So we're going to move on, please, until we get to analysis and conclusions, which is on page 25. Okay, this is just a review of something we've already done earlier on in the lesson. So adding water or solvent to a solution will make it more dilute. And you know that if you think about making squash, you can make weak squash by adding more solvent, more water. You can also reduce the amount or mass of a solute, so use less of the actual squash, okay, to make it more dilute. Okay, and the opposite of those will increase the concentration. So this is what we covered on page 24 in this table here. Okay, so it's just a re-explanation of these points. And you'll have seen that, for example, with squash, when you add more water, the squash looks weaker, it looks more dilute because it's not as bright and colourful. Okay, so it's very obvious with, say, red squash or Ribena. You can make Ribena look really dark purple, or you can make any red squash look really dark, deep colour. But if you add too much water and it becomes too weak, it's going to look like a very pale pink colour, okay? Because it's become more diluted and the colour intensity has reduced. And that's just because the colourful atoms that are making the colour are more spread out. Because there's a lot more water and they're dilute and spread out within that water. Okay, so now we're going to look at converting between grams to decimeter cubed to moles per decimeter cubed. So you'll notice they're both per decimeter cube. Okay, when you're converting units that are like this, they've got 2 parts to them, you should only ever change one part of it. So we're converting the gram part to moles and vice versa. So to convert the concentration from grams to moles, use this equation here. So moles, so whatever your concentration is in moles, it equals grams divided by the relative molecular mass. Okay, and we can rearrange this. Okay, so sometimes we use an equation triangle to do this, so I will draw that out. This here is the dividing line, and then we have a multiplying line. So we have grams. Okay, so that's the mass in grams. Here we have moles. Okay, MOL. Okay, so that's the amount in moles. And here we have the relative molecular mass. Okay, so we've got grams, moles, and relative molecular mass. So our equation here is moles is grams divided by the relative molecular mass, so we've got that one written down. Now if we want grams, it's going to be moles multiplied by the relative molecular mass, so we can write that out. Or if we want the MR, it's going to be grams divided by the mass in moles, the amount in moles. Okay, so we have our two alternate versions of this equation. So grams equals moles multiplied by the relative molecular mass, and the relative molecular mass equals grams divided by moles. And you will need to be able to use these. We're going to have some practice at this in a minute. So for example, the concentration of hydrochloric acid is 73 grams per decameter cubed. To convert to moles per decameter cubed, we just divide it by the MR, okay, which is fine. So we take our 73, which is our amount in grams, which is here. We divide it by the relative molecular mass of hydrochloric acid, which is 1 plus 35.5. Okay, and so that gives us 73 divided by 36.5, which gives us the answer of 2 moles. So what I want you to do now is I want you to watch this video clip on YouTube. If you've got a copy of this digitally, you can click the link, which will make your life easier. Okay, and pause this video whilst you watch the YouTube clip. Please make some notes on the student notes page, please, as we go through this, because we're going to be doing these calculations in a minute, so you need to be quite comfortable with doing them and how you do these. So pause the video whilst you do that, whilst you watch that video. So there are 12 questions. They go on this page and on to page 26, where you can see the remaining questions. They do get trickier as you go through. Okay, so we'll do the first one together, and then I want you to go through the rest of them on your own. And they do get trickier, and you do need to use different versions of the equations in this lesson. So if you're not sure or you're stuck, have a look back through this lesson and see, how can I rearrange this equation? What have I got? How can I do this? So let's review. We'll start with question 1. Calculate the concentration. Okay, so it wants us to calculate concentration in grams per decameters cubed. Okay, so it wants concentration. Then it tells us we've got 4 grams of sodium chloride, and it's been dissolved into 0.5 decameters cubed of water. Okay, so the first thing we need to think about here is, well, what's the equation I need to use? So we need that equation for concentration to calculate concentration, and that equation is back on page 24. So here's the equation. Concentration is mass divided by volume, or concentration is amount divided by volume. Well, we have a mass in grams, so we shall write this out. I'm going to use red just to help you so you can see it better. So I'm going to use the shorthand conc, C-O-N-C, with a dot to indicate that means concentration, and it prevents me having to write the whole thing out, and it's allowed to be used like this in science lessons. So concentration equals mass divided by volume. Okay, now we can put the units in. Well, what is our mass? Our mass is 4 grams. But is it 4 or 4.0? So we're going to write it as it is, 4.0 grams. Okay, we're going to divide that by the volume, which is 0.5 decameter cubes. And when we do 4 divided by 0.5, and please do use your calculator because you're always allowed a calculator in science lessons and in your exams, the answer you should get is 8 grams per decameter cubed, just like that. Okay, so you'll need the same equation for this one. This one here, you'll notice that we're no longer using grams per decameter 3 for our answer, we're using moles per decameter 3, and that the amount is given in moles instead of in grams. Okay, I highly recommend, as you're doing this, that you highlight the key information, okay, that you're being asked for. So you want concentration in this. So this is what you're being asked for. These are the 3 things you need. Okay, and when you get onto the next page, it'll be a little bit trickier because you'll need to start rearranging the equation around about question 7. But we've shown you how to do that, okay, and that is further up on page 25. So if you need to rearrange the equation, all the information you need is here. So pause the video whilst you do those questions. There are 12 of them. It will take you a while. Don't worry about that. If you're not confident that you're doing well, feel free to do a few of them. Pause the video whilst you do those, and then watch the first few answers, check you're getting it right, and then go back and do some more and keep doing that. You do some questions, check them with my answers, okay? And you can do it that way if you're not confident and you don't want to do all 12 of them wrong. Okay, so pause the video now whilst you work through those. Okay, so let's mark those. Each of these questions is going to be worth at least 2 marks. Some might be worth more. So first of all, question 1, you get 1 mark for writing 4 divided by 0.5 and 1 mark for coming up with the answer of 8. Question 2, you get 1 mark for writing 4 divided by 500 and 1 mark for coming up with the answer of 0.008. You're not getting marks this time for units because you're being given the units to use in the question. But if you weren't given those units in the question, you would get a 3rd mark for the units you require. So question 3, you get a mark for writing 1 divided by 0.2 and a mark for the answer of 5. Moving on to the answers on page 26. Question 4, you get a mark for writing 1 divided by 100, giving us an answer of 0.01. Question 5, you get a mark for doing 30 divided by 2, which gives us an answer of 15. So we're still using the concentration as mass divided by volume or amount divided by volume here. Question 6, you get a mark for doing 2 divided by 20,000, so that's a comma after the 20 if you've put it in, not that you need to. But make sure that's 4 zeros after your 2 here. And your answer is 0.0001, so that's 3 zeros after the decimal place. Question 7. Okay, so question 7 involves us rearranging the equation here. Okay, so now we have the mass equals concentration multiplied by volume equation. So your first mark is for doing 12 multiplied by 0.5. Your second mark is for the answer of 6. Question 8, it's the same equation. Okay, so it's second chance to get this right. 3.2 multiplied by 200 gives us 640. Question 9. Now we're just using a different version of this rearranged one, so it's amount is concentration times volume instead of mass. So a mark for 0.1 multiplied by 12 and a mark for 1.2. Now this time you get a mark for giving the units of moles, and in fact on question 8 you get a mark for giving the units of mass as well. As well as question 7 you get a mark for giving the units. So question 7, 8 and 9 are all out of 3, okay? Because you're no longer being given the units for those. Okay, let's move on to question 10. Okay, so this time it's still the same equation. Amount is concentration by volume. So 0.4 multiplied by 2, you get a mark for writing the correct answer, which is 0.8, and you get another mark for giving the amount in moles. So that one's another 1 out of 3. Question 11. Okay, so we've rearranged the equation again. So now its volume is mass divided by concentration. So 4 divided by 2 gives an answer of 2, and it hasn't given us our units in the question, so you get a third mark for using decameters cubed. As an aside, if you've written moles instead of mol, that's fine. Okay. And last question, question 12. It's similar equations. This time it's volume equals amount divided by concentration, okay, because we're dealing in moles. And that's 1 divided by 2, which gives us 0.5. And we get units for that, which is decameters cubed. So that's also out of 3. Okay, so I'd like to give yourselves a mark, please. So the first 6 questions were all out of 2, giving a total of 12 marks for those, and the second 6 questions were all out of 3, giving you a total of 18 for those. So the whole thing is marked out of 30. So if you could give yourself a mark out of 30. If you've got 20 or more, then you've done very well, so well done. If you've got less than 10, then you need to have another go at those questions, please, because that shows that you've really struggled with the rearranging, or that you've not been showing any working at all, which is a problem. Okay, so please make sure you're showing all the steps of your calculations and giving units, please. Okay, we're going to move on. So we're on to page 27 now, and it's checkpoint. Checkpoint question. A student wants to react nitric acid with potassium hydroxide. So the reactants are nitric acid and potassium hydroxide to form potassium nitrate and water. So those are our products. Question A. What is the balanced symbol equation for this reaction? That's worth 2 marks. Question B. For question A, you'll need to make sure you're writing that in symbols. So, for example, the symbol for water is H2O. Okay, so make sure you use the symbols for your first question. Question B. Student dissolved 14 grams of potassium hydroxide in 700 centimetres of water. Calculate the concentration of the potassium hydroxide solution in grams per decameter cubed. And that is worth 2 marks. You should be quite good at this now, having done all those questions. Part C. The concentration of nitric acid was 22 grams per decameter cubed. Calculate the mass of the nitric acid in 30 centimetres cubed of solution. That's worth 2 marks. And again, you should be quite good at that now, having done those 12 equations. Just a note to remind you about B and C, just for some hints. Don't forget that you will need to convert centimetres cubed there into decameter cubed, because you are given 700 centimetres cubed of water, okay, but it wants the answer for the concentration in grams per decameter cubed. So the first thing we're going to be doing is converting that to decameter cubed. Question C, same concept. It's got concentration in decameter cubed, but the mass, the amount of solution is 30 centimetres cubed. You need to convert that to decameter cubed first. Okay, so you've had your hints. You pause the video and then we'll go through it together. Okay, so let's review the question. Question A. So the balanced symbol equation for this reaction. So you just need to know the symbols for this, really. It's balanced as soon as you write it out. So HNO3, that's 3 subscript, plus KOH. So if you've got both of those, you get a mark for getting the reactants correct. And KNO3 plus H2O, you get a mark for getting the products correct. So that's 2 marks there. Question B. 700 centimetres cubed divided by 1,000 makes 0.7 decameters cubed. Okay, so that's your first mark, converting the centimetres to decameters cubed. Okay, and your second mark is for doing the equation and getting an answer of 20 grams per decameter cubed. Okay, so you can have this first mark either for doing this, 700 divided by 1,000 gives you 0.7, or you can get it for doing 14 divided by 0.7 to indicate that you've done the conversion already. Okay, so you get the mark here for one of these two. So it's a maximum of 2, and one of the marks must come from the answer of 20. At question C, again, first mark is for doing the conversion, so 0.03 decameters cubed. Alternately, you can get this first mark for writing 22 multiplied by 0.03, which shows us you've actually done the conversion here. Okay, so it's one of those two for the mark. And then the second mark is for writing 0.66 as your answer. And again, that's out of 2. So give yourself a mark out of 6 for this. If you've got 4 or more, then you've done very well. Well done. If you've got 2 or less, then you need to review this and see where you've gone wrong and what was it you didn't know. Is it that you didn't know the symbols for nitric acid, HNO3, or potassium hydroxide? Okay, in which case that's a bit tricky and you'll get there, but you just need to practice using those and balancing equations. Or was it that you didn't know how to do the conversions, or that you did the equations wrong? What was it there? Try and figure out where you went wrong, and feel free to rewatch that part of the video where I go through it. We'll move on to the final part of this lesson, which is the knowledge and application check on page 28. There are 12 questions, so quite a lot. So pause the video whilst you work through those and complete the questions, and then we'll go through them together. So let's go through those questions. Question 1, define solute. Well, it's the dissolved substance. Question 2, define solvent. It's the liquid used for dissolving. Or it could be the liquid that the solute dissolves into. Question 3, define solution. So that's the solute dissolved into the solvent. Question 4, state the 2 units for measuring volumes. So that's centimetre cubed and decameter cubed. You'll need both of them for the mark. Question 5, state the units for measuring amounts of atoms or molecules. Well, that is moles or mol, M-O-L. Question 6, calculate the concentration of 8 grams of salt in 500 centimetres cubed of water. Well, 500 centimetres cubed divided by 1,000 is 0.5 decameters cubed, so you can have a mark for that part. Then the concentration is the mass divided by the volume, which is going to be 8 divided by 0.5, giving us 16 grams per decameter cubed. Now, you can have the mark either for doing the 0.5 decameter cubed conversion or for doing this part, 8 divided by 0.5. Okay, so it's a maximum of 2 there, and 1 mark must be for the answer. Question 7. State the equation for calculating concentration if you know the mass. Well, concentration is the mass divided by the volume. Question 8. What's the equation for calculating concentration if you know the amount? It's the same equation except swap in the word amount for mass. So concentration equals amount divided by volume. Question 9. Describe one way to reduce the concentration of a 1 molar per decameter cubed of hydrochloric acid. Well, you could add more solvent, add more water. Question 10. Calculate the concentration of iron sulfide solution in grams per decameter cubed if 20 grams of it were dissolved in 200 centimetres cubed of water. So again, you need to do your conversions. So 200 centimetres cubed divided by 1,000 gives you 0.2 decameters cubed. There's 2 marks again available for this. So if you haven't written this out, but you have written 20 divided by 0.2, then you can have the mark for this part instead. And you get the final mark, the second mark, for writing 100 as your answer. So that's out of 2. Question 11. Very much the same concept. So calculate the concentration of iron sulfide solution in moles per decameter cubed if 0.4 moles were dissolved in 50 centimetres of water. So this is one of those examples again where you have to read the question to notice what it wants its answers in. Okay, so 50 centimetres cubed divided by 1,000 gives us 0.05 decameter cubed. Concentration is amount divided by volume. So if you haven't written this equation here for the conversion and you've done 0.4 divided by 0.05, you can have the first mark for that instead. And the answer is 8. So again, that's out of 2. Question 12. Calculate the number of grams of sodium chloride dissolved in 100 centimetres cubed of water to make a concentration of 25 grams per decameter cubed. Again, The units are different between the two, so you need to do a conversion. So 100 centimetres cubed of water divided by 1,000 gives us 0.1 decilitre cubed. If you haven't shown this conversion, but you have written 25 multiplied by 0.1, then you can have the first mark for that instead again. And your answer is 2.5 grams, giving us another 1 out of 2. So add up your marks, please, and give yourself a mark out of 16. If you have 10 or more, then you've done very well. If you have 6 or less, then you need to review this lesson because it shows that you've had some serious issues with understanding what to be doing in this lesson and what we've done. So I would review the lesson if you've got 6 or less. Okay, and that's the end of our lesson. If you have any questions, please feel free to email your teacher. They're very happy to help you if you're in any way stuck. Thank you very much.